This video is about the classification of matter. Chemistry is the study of matter, and so we need to know how to classify it and talk about it. Remember that matter is anything that occupies space and has mass. There are three principal states of matter that we're concerned with in chemistry. There are solids, liquids, and gases. The transition between these phases are some vocabulary words that you need to know. You probably know most of them. When a solid transitions to a liquid, that is known as melting. Liquids going to a solid is freezing. Liquids going to gases is called a boiling point. Gases that go to a liquid is called condensation. Let's talk about some physical properties of solids. The particles are very organized. They're very close to one another. The particles are still moving, but they're only vibrating. You can't really compress a solid because the particles are so close to one another. They have a definite shape and a definite volume. Liquids, the particles aren't as organized. The particles are still close, but they're not necessarily touching. These particles can rotate, which means they can spin around. They can translate, which means they can move from place to place, but only a little. You can't compress a liquid because they are still close to one another. Volumes are definite in liquids, but liquids do not have a definite shape. Liquids are said to take the shape of the container that they're in. Gases have completely random positions. The particles can rotate and translate. They're far apart from one another, and so when pressure is applied, they can be compressed. They don't have a definite shape and they don't have a definite volume. They will expand to the volume of their container. So one more time, here are the vocabulary words for different transitions in the phases of matter. So we talked about all of these phases here, the melting and freezing and the vaporization or evaporation and condensation, but we didn't talk about when a solid directly transitions to a gas. That is known as sublimation, or when a gas goes directly into a solid, that's called deposition. So know all of these vocabulary words for transitions in matter. There are two more states of matter that we really don't concern ourselves with in chemistry, but in physics you would. There is a state of matter higher in energy than gas. It's called plasma. This is superheated ionized gas. They have high electrical conductivity, and they can be influenced by magnetic fields. A Bose-Einstein condensate is matter that is cooled to almost absolute zero, and the particles then exhibit wave-like behavior. This is the classification of matter. We can take matter and classify it into a pure substance or into a mixture. If it is a pure substance, it can be classified as an element or a compound. Examples of elements are oxygen or hydrogen. A compound could be salt, water. If it's not a pure substance, matter is then a mixture, and it can be homogeneous, which means it's uniform throughout, such as air or alcohol and water, or it can be a heterogeneous mixture where it's not uniform throughout, like oil and water and salt and pepper. Elements are pure substances, as we saw in that classification slide. Elements are made up of one type of atom, and all of these atoms have the same number of protons, and we'll talk about protons in chapter 2. They cannot be broken down using chemical means. Currently on the periodic table, there are 118 elements. The elements are arranged on the periodic table based on their number of protons. There are 7 elements that are diatomic. So this is a pure element that naturally exists with 2 identical atoms that are chemically bonded together. The 7 diatomic elements are hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. So when you write these, if you were going to say hydrogen, you would say H2, or oxygen or chlorine, any of these diatomic elements, you put a subscript 2 below the symbol for the elements. A compound is also a pure substance, but it's when 2 or more elements are chemically combined in a specific ratio. Here we can see we've got something red, and then another element, because it's a different size and a different color, chemically attached, and it's in a ratio of 2 to 1. A mixture is when you have 2 or more elements or compounds that are not chemically combined. So for instance, this is air. This probably is nitrogen or oxygen, they're diatomic. This could be CO2 or it could be water, probably water. This is probably CO2. Notice that there is more than one type of matter in this sample. Types of mixtures, again, can be homogeneous. That means that the composition is uniform throughout. Homogeneous mixtures are called solutions. Heterogeneous mixtures is where the composition is not uniform throughout. So here at the top we would have one type of matter, and at the bottom we would have a different type. So let's go ahead and practice. So in this very first one, we see here, and you should, if you clicked on classification of matter handout, you should have this in a PDF, or we can just look here. In number 1, we have 3 different atoms. They are bonded together, and everything is the same, so this would be a compound. In the next one, this looks like it is a mixture because it is more than one type of matter, and they are all elements, so this would be a mixture of elements. In this next picture, we see this is an element because it's a diatomic, and then this is a compound. So this would be a mixture of a compound and an element. The next one, number 4, it looks like all of them are compounds, but not every compound is the same. So number 4 is a mixture of compounds. The next one is an element, and number 6 is a compound. These are called particle diagrams, and if they're touching, then they're bonded to one another. And if there's more than one type of atom, that's known as a compound, and so forth. We can continue on with more practice with your sheet, and I'll just give you these answers. The top 3 up here, but this is 13, 14, and 15. These are all mixtures of compounds. Number 7, that is an element. It's a diatomic element because there's 2. This is a mixture of elements and compounds. This is a mixture of elements. We have a diatomic element as well as an element. The next one is a mixture of elements and compounds. Number 10 is a compound, and that was number 11, excuse me, and this is number 12, is a mixture of compounds. All right, so let's practice counting atoms in a compound. There will be a subscript after an element symbol that will tell you the number of atoms in a compound. If there is no subscript, it is assumed to be 1. So here we've got NaCl. There are no numbers, so we assume that there is 1 sodium and 1 chlorine. In CaF and then a subscript 2, there's 1 calcium. This subscript of a 2 after the fluorine indicates 2 fluorines. K2S, K is potassium. The 2 indicates 2 atoms of potassium for every 1 sulfur. If there are parentheses in a formula, the number outside the parentheses will distribute through everything inside the parentheses. For example, in magnesium hydroxide, Mg, there's only 1 magnesium. Then there's parentheses, and there's a 2 outside the parentheses. The 2 will distribute through to everything in the parentheses. So we have 2 oxygens and 2 hydrogens. The next one, you're going to learn how to name these later. This is called iron 2 nitrate. 1 iron, 2 nitrogens, and then 3 times 2 for 6 oxygen atoms. The next one is aluminum sulfate. We have 2 aluminums. The 3 distributes through. We get 3 sulfurs. 4 times 3, we have 12 oxygens. Let's talk about physical properties and physical changes in matter. A physical property is a characteristic that can be observed or you can measure it without changing the identity of the substance. Physical properties include things like color and hardness, their melting points, electrical conductivity, malleability, solubility, boiling points, etc. Physical changes are when the substance will change, like state of matter change, but its identity does not. So for instance, melting, boiling, those are physical changes of matter. It's H2O when it's liquid water, and when it boils into steam, it's still H2O. When you dissolve a solid into a liquid, that is still a physical change. So if you put sugar into water, the sugar seems to disappear, but the water does get the sweet flavor of the sugar. But if you evaporated away all of the water, the sugar would still be in the form of solid sugar. When you cut or you break something, you are making a physical change. Physical changes can be reversible, or some of them are irreversible. Chemical properties are properties that change the composition of the matter. So if something rusts, or if it decomposes, or it burns, those would all be examples of a chemical change. This is when bonds are broken and new bonds are formed in the matter. Some examples would be photosynthesis that you may have learned in biology. You started with carbon dioxide and water and you get glucose and oxygen, or the reverse of respiration. Signs that you may have a chemical change in a lab would be if you get a production of a gas, you'll see some fizzing and bubbling. Sometimes during a chemical change, there will be a temperature change. You might form a precipitate. That is what is in this picture over here. You have 2 clear liquids. When they're mixed together, a solid forms, and you could have a change in color. When we are measuring matter, there's 2 different types of properties. One is called extensive. Extensive properties depend on how much matter you have. For example, the mass, the volume, or the length. The more matter you have, the greater its mass. Intensive does not depend on the amount of matter. So the boiling point of water in Celsius will always be 100 degrees no matter how much you have. Same with melting point. The density of water is 1.0 grams per milliliter no matter how much you have. These are known as intensive properties. I hope that this video helped you understand the different types of matter and how to classify it.